there's a bunch of stuff that you have to take into consideration in order to have a complete environment at a customer's site up and running at your data center. Talk to me about that. There's a lot that goes on behind the technical side that it's not a flip of a switch. Hopefully it is, but there's a lot of work that has to be done to make that happen.
It's like building a house. Yeah, there's a lot of steps, right? To get an operation running somewhere else. So, but yeah, that process of taking all of the steps to build the house or to build the recovery environment, that's referred to as orchestration. Orchestrating those steps, prioritizing them, putting them in order, and once they're orchestrated or lined up, you can automate that process and really shrink the timeline that it takes to execute those steps.
Okay, so there's a lot of planning involved, and that's where the runbook comes into play, because you have to. Okay, so you plan it all out, you put the runbook in play, and then there's obviously testing that has to be done, because with technology and new applications and updates, you never know what's going to happen. Let's see. Can you give us an example of a successful cutover for a client that a disaster happened? From kind of from start to finish.
Yeah, I guess an example of that, Court, would be a customer that called us up because they ended up having an emergency power outage. It's a 30-story skyscraper out in Beverly Hills, and there was a transformer that exploded, and it was related to some construction that was going on in the area. So the notice is immediate. Power's out. Of course, there's UPSs in the building. Maybe they have 15, 20 minutes of runtime on them, and the message comes all connected. Okay, we're declaring a disaster. So
this had nothing to do with the customer's equipment. It was completely out of their control. It was the power company had a problem. So, okay.
Then you got a building or buildings in a wide geographic city block that have no power, and there's no ETA on recovery of the power from the local utilities. Yeah.
Okay. So power, internet, everything's out at the skyscraper. You got the notice. What happened next?
Yeah. So the first step is the disaster recovery call, or the declaration of the disaster. It's, hey, we're going to be down. This is a prolonged period of time. And often during the declaration of a disaster, our team has to assess, is it possible that this might not really be a disaster? Like power could come back on in 10 minutes and it's better just to wait, because whenever you fail over, of course, there's a fail back process. And those both have to be synced pretty well. But once it's discerned by contacting, in this case, Southern California Edison, determining the power outage is going to be sustained, it's a real impact to the area, and it's going to take a lot of engineering to get it fixed. Now we realize, okay, this is a disaster, and so that starts with the formation of the disaster recovery team, which in our case we use a WebEx type of a tool set to bring in the team members into that declared disaster. And that way communication can be real time. Engineers can hop on the call, hop off the call as necessary, but the team's formed at that time.
Let's see. So after the team is formed, what's the next step?
Yeah. So immediate step is check the status of the last replication. Okay. It depends on the RPO time. If the RPO for that customer was 6 hours, well, we want to go back and find out, okay, when was that last 6 hour interval versus when the disaster happened, because that's going to tell us how much potential data was lost. And so that's important communication back to the customer. I don't remember the exact RPO, like where it fell on the clock, but for instance, if their RPO is at 2 a.m. and the disaster happens at 6 a.m., right? You got 4 hours of time that's gone by since the last snapshot. So that's just important to communicate to the client. Okay, we got snapshots across the board as of 2 a.m. We're going to roll over the recovery environment with a 2 a.m. state. Okay. And in most cases with customers, it's like, well, we don't do a whole lot of work from 2 a.m. to 4 a.m., or 2 a.m. to 6 a.m. It's not a problem.
Yeah.
Yeah.
Okay, that makes sense. So that's communicated to the customer. And then what's the process of getting them, back up and going on on your infrastructure?
Yeah, so the recovery book is consulted. We end up learning from the recovery runbook any nuances or instances with that customer that make them unique. And there's a lot of things that happen. In the original test, which happened, months earlier, if it's the first test, you learn a lot. It's like that move, right? You move over to the new location and you're like, oh, we forgot some licensing, or there's a problem with, whatever, a switch or a router or a dependency that a database had that you realize this has to come up before this happens, right? So that runbook and the orchestration from that runbook help us to make sure that we're prepared for the recovery of that environment. But after consulting that, reviewing with the customer, we basically initialize the recovery environment. Because it's orchestrated, it takes just minutes to initialize the recovery environment, and then basically the machines are put into a spun up state. So the engineering team would then look at the environment to make sure that all of the components that are supposed to be up and running are up and running, and then once that's validated, we get ready for the next step, which really has to do with the network and client access.
Okay. So once you consult the runbook, you spin up the machines that you have on your data center that are hydrated, make sure everything's good on that side of things, and then you work on the connectivity to make sure that the client can connect back to your infrastructure instead of their infrastructure.
Yeah, that's right. Yeah. And again, that's why testing's so important, right? That depending on the kind of customer, issues related to BGP could be involved, DNS failovers may need to be involved, time to lives we may need to make sure that those were set right. Hopefully they were, because the test ended up updating the time to live so that we can end up failing over DNS relatively quickly. Some applications, the end user may need to go to a portal. Other applications may be tied to another URL that's tied to an IP address. That it's really important that mapping and that DNS failover happened. So all those items are identified in the runbook during testing.
Right. So those are some of those idiosyncrasies with each individual client and application that you identified during the testing phase.
Yeah.
So.
Yeah. In one case, when we had the California fires hit, some of these disasters, you would think, okay, there's plenty of warning time, like a hurricane or fires. They're moving at a particular speed. We had a case in California where the fires were moving at a football field a second when the winds really kicked up. And we got a call from a customer. We had checked in with them, the night before, but we got a call from them early in the morning. It was they saw their building on the news with the fire trucks in front of it. They thought they'd go to bed okay, and they woke up with trucks surrounding the entire building, and basically now they couldn't get in or out. The streets are cordoned off, and now it's really difficult. But in those cases, sometimes you got customers with ties like they did. A dedicated link or pipe over to AWS, another link or pipe over to Azure. You got to know how those pipes are built, how those pipes are authenticated, and that was an important aspect of the recovery operation. If you don't have that information, or you don't extract that information out of an engineer's head during the testing process, it's really hard to return them back to operations in the event of a disaster.